Hello everyone, my name is Alicia Baldwin and I am a sophomore mechanical engineering student at Clemson University, and I would like to talk about the subject of microchannels and their effect on healthcare. I first got interested in microchannels whenever I joined a research group that allows undergraduates to work with PhD students on fluid mechanics and on a molecular scale. This means that instead of working with water flowing through a normal sized pipe, we work with water that flows through tubes and channels about the size of a strand of hair, which is really small. And whenever water is flowing through channels that are that small, they flow at about the same rate that you can imagine honey would flow through a normal sized pipe, which is really slow. And this system has been used to separate particles from fluids. For instance, whenever someone has diabetes, they prick their finger and they send that drop of blood that's on their finger into a blood glucose monitoring system. And that system is basically a series of different channels. And those channels have been designed to remove the glucose from the person's blood. So the glucose gets removed and the rest of the blood is able to flow throughout the channels. And by the end of the process, the device is able to read to the person how much glucose is in their blood, which is very helpful for people to know when they need to eat or if they need to monitor their eating for that day. Part of our study is we want to further advance the system of microchips and allow people to separate even more particles in blood or in water or any other fluid that someone would like to test. For example, I have drawn a diagram of one of the channels that we've been working with. We wanted to know the influence that magnets can have on this process of separating fluids in a microchip. And this can be seen in 4 separate steps. In step 1, we have a magnetic fluid that we call ferrofluid and really small particles on the left side. And then on the right side, we have water that we've mixed in particles that are still really small, but not as small as the particles that we've mixed into the magnetic fluid. In part 1, both the different fluids have their own separate and respective tubes that they flow through until part 2. By part 2, they are both in the same tube and they're able to flow through, and they stay separated in part 2 as well as they're flowing down this tube until they reach the influence of the magnet, which can be found in step 3. In part 3, the magnetic fluid with its extremely small particles both get attracted to the magnet and they move over to the right side of the channel. And this movement causes the water and its larger particles to shift over to the left side of the channel. And by the step 4 at the end of the channel, we've now been able to control where the particles are by the magnetic fluid being attracted to the magnet and moving over to the other side of the tube. And this process and research we're not exactly creating chips, but we are figuring out processes to better control the fluids, which will help advance microchips and how they influence healthcare. Thank you so much for watching my video and have a great day. Bye.